This video will show you how to complete the problems on page 30 out of your math book. It says to color the squares below so that the probability of selecting a blue square is 4/5. So at first you might be like, oh, I just have to color in 4 of these as blue. But when you count them, you're supposed to have 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, we have 10. So you can't go 4 out of 10 because 4/10 is not the same as 4/5. So what you need to do, this kind of stems back into your equivalent fractions and proportions. We need to make this 4/5 out of 10 because there's not 5 here, there are 10. So 10 is the whole. Well, how can we find an equivalent fraction to 4/5? You got to ask yourself, well, how did we get from 5 to 10 using multiplication or division? Well, we used multiplication and we multiplied by 2. So if you do that to the denominator, you have to do that to the numerator. 4 times 2 is 8. Okay, so 4/5 is equal to 8/10. So in this case, since there are 8 blocks right here, I need to color 8 of them blue. Okay? Okay, so you see the probability of selecting a blue one is 1, 2, 3, 4, 5, 6, 7, 8, 8 out of 10. Which simplifies down, let's see, divide by 2 to 4/5. Okay, so that's why this is equivalent to this. All right, problem number 4. It says students are playing a game that requires the spinning of the 2 spinners shown below. A student wins the game if both spins land on red. Okay, so we want both the spins to land on red. What's the probability of winning the game? So to win the game, we need red and a red. We want a red here and a red here, and then you win the game, okay? So their little hint is remember to first list the sample space and the probability of each outcome in the sample space. There are 8 possible outcomes to this chance experiment. Okay, so I'm going to do what they tell us first, okay? They want us to list the sample space. Hint right there is do a counting tree, also known as a tree diagram. So let's go ahead and do that, and then I'll show you another way to do this, okay? And you can pick whatever way you like better. I'm going to give myself some room, so I'm going to restart. Okay, so for this first one, because remember we spin each of these spinners 1 time each. So start, I can land on red or blue. I'm just going to abbreviate. You can write it out if you're bored. Whoops, yeah. Okay, red and blue, red or blue, and that would be that first spinner. Okay, so for this second spinner, again, these are independent events because whatever I land on over here doesn't impact this one over here, okay? These are all still there for me to pick. Nothing's taken away. So if I land on red first, when I go to spin the second spinner, these are all the possibilities I could totally land on, okay? So from this red branch, I can land on red in that spinner. I can land on blue. I can land on yellow. Or I can land on green for that second spinner. Well, let's say I landed on blue on the first spinner. When I go to spin that second spinner, you can land on red, blue, yellow, or green. Same options. Okay, and just to keep ourselves organized, you're going to label that second spinner. Okay, so now you know, oh, okay, I've got the information for this guy and this guy. Now we can go ahead and list our sample space. And again, I'm doing that in a different color so that you know that these are different than that next column, which will show the sample space. So we can have red, 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 blue. It helps if you trace it. Red, yellow, red, green. We can land on blue and then red. Blue and blue. Blue and then yellow. Whoops, blue and then green, okay? So we have 1, 2, 3, 4, 5, 6, 7, 8. 8 possible outcomes, 8 in the sample space. Remember, possible outcomes are also known as the sample space in spinning each of these spinners 1 time. Okay, so what was the question again? What's the probability of winning the game? To win the game, you want red and a red. So is that a red? Oh, there it is. Winner. Any other reds and reds? Nope. So the probability of winning this game is equal to 1 out of how many? Well, that's why I like you to count them. Remember I told you I like you to count them? I already know there's 8. 1 out of 8. Okay? Or you can write that as a decimal. 1 divided by 8 is a 125 thousandths, which is, as a percentage, 12 and 5/10%. Okay? So there's our winner. All right, I told you I was going to show you another way to do this, and I'm going to go ahead and show you that right now. Okay? So you think about it, this is an AND problem. And what I mean by that, in probability, the word AND, only in probability, means to multiply the probabilities of each of the events happening, okay? So, like I said, we want red and red. So we want to find the probability of landing on red and a red. That's the only thing we can have, not red or red. You got a red on this, and you better have a red on that to win. Okay? And that's going to be to win. So the probability of landing on red on this guy right here is 1/2. Okay? And then the probability to land on this guy over here is 1 out of 4. And then, and only in probability will and mean to multiply. Okay, so look, you got fractions here, you're multiplying the fractions, and you can just go straight across. Numerator times that numerator. 1 times 1 is 1. Well, I'm sorry, I'm writing it up there. It's all smushed. And then 2 times 4 is 8. Boom. The probability of winning, getting a red and a red, is 1/8, which, isn't that exactly what we got over here? 1/8, or I can write it as a decimal, which is 125 thousandths, which equals 12 and 5/10%. We get the same exact answer, okay? So you can always do a counting tree, also known as a tree diagram, or you can do it this way. But you got to know if it's an AND problem or an OR problem. It specifically says you want red and a red, so you know you need to multiply. Okay? If it said red or a red, if you could get a red on this one or this one and win, then that would be an OR problem where you would just add the probabilities together. But this specifically says to win you need red and red. Okay? Bye.